This is the fourth video for the 6 to 8 lesson on the proof of the Pythagorean theorem. It says on the grid, use your knowledge of right triangles in the Pythagorean theorem to sketch a square ABCD that has an area of 40 square units. And then in the text box below, state the area of the two squares that helped you create the third square. Okay, so 40 is not a perfect square, and it shouldn't be because the idea here is that they're going to give us tricky values for this. So I'm going to build a right triangle, and I'm going to try to place it in the middle. I'm either going to use that tool or my line segment tool, or plot points like this. Okay, so 40. Well, I need to think of if I have a square that is 40, let's just make an ugly drawing here, and it's probably going to come off of the hypotenuse. What are the squares need to be that are here that would equal 40? Well, 39 and 1 is an option, but drawing a square with an area of 39 is going to be difficult. One would be pretty easy. So I need to find two numbers here that work well with squares that are drawn vertical and horizontal. Basically, I need two areas that are perfect squares. So let me think. 25 and 15. 25 would work, but 15 is not a perfect square, but 25 plus 15 is 40. So I'm going to keep trying these and thinking. What about 36 is a perfect square and 4? Ah, yeah. Okay, so we're going to draw this. So 4. 4 would mean in 36. 1. Okay. So I'm going to now use maybe this line segment tool to draw this in. And there is, or my pencil tool if that works better. Okay. So there is an area of 4. And here is my area of 36. Okay. And then I'm going to draw my square off of this. But it needs to use the same slope of 2 and 6. So it's going to be right there. So it's going to be, instead of down 2 and right 6, and I want it to form a right angle, I'm going to do the opposite reciprocal like I did with perpendicular. Or if I want to, I don't have to do this, but I could draw in that right triangle again. So I'm going to do that over here. I'm going to go up 1, 2, 3, 4, 5, 6, and right 2. Oops. Might erase sort of how I drew that because might want that more like that. Okay. And then, in fact, if I can just erase a lot of that. What I was trying to do, really wanted that triangle there just so I could have kind of the classic looking Pythagorean theorem. So this square has to be 40 units. And I could use what I learned in the 6-1A lesson of breaking up shapes to prove that, but I already know that's the case. So I'm going to then type in here that I used 4 and 36. Some problems might have more than one option, but usually there is one primary choice on how to do this. So we want two squares that are built off of the legs that are vertical, horizontal for sides, and then one square that's leaning or tilted or rotated off of the hypotenuse. We're going to look at one more example. And we're going to look at one that has instead building a line segment. So this one says we're going to try to build a line segment that is root 8 units long. Well, essentially what that's saying is I want to build a square that's 8 square units, because a square that has an area of 8 square units has a side length of root 8. So I need to find or think of what are some perfect squares, like 1 and 7. No, 7's not good. That will add up to equal 8. What about 4 and 4? So we're going to build a 2 by 2 right triangle. And these are 4 and 4. And so that line segment right there is square root of 8. I technically don't need to draw in the square unless I really want to, which of course I want to because it's fun. And I'm going to use my slope or kind of build my flanking. See if I can do this correct this time. There we go. And so then that has an area of 8.